We just found extreme values for this function on the interval from 0 to 3. Before we move on, I want to talk about relative extreme values. In particular, I want to talk about relative minimums and maximums. Let f be a function defined on interval I containing c. The precise definition of relative minimum is the following. If there is a delta greater than 0, such that f of c is less than or equal to f of x for all x in the interval I, where x minus c is less than delta, then f of c is a relative minimum of f. We say that f has a relative minimum at the point c comma f of c. That's some fancy language, but what that really means is that it is a minimum around the points, among the points around it. So f of c is a minimum around the points where it's at. I'll do a visualization of this in a minute. However, the same thing holds for maximums. If we have a relative maximum, that means it's bigger than all of the other points around it. So a relative minimum is a point which is smaller than the points around it, and a relative maximum is bigger than the points around it. Relative maximums and relative minimums are called relative extrema of function f. So relative maximums and relative minimums are what we are going to concern ourselves with. Let's graph the following function and try to find the relative extrema of this function. I want you to go ahead and try that using the approach we dealt with before, and then look at the next video and see if you got it right. So graph this and find the relative extrema of the following function. And when I say this function, I mean from negative infinity to positive infinity. So there's no interval here. I mean over the entire real number line. Go ahead and try that and then watch the next video.